Good afternoon and welcome to your subject and math side 22, agricultural biology. So last time we are already done with our unit 1, the introduction to biology, and you can just go back into the videos here posted. So if you miss it and then you just review it again. So we are now on unit 2, which are life processes. So we're going to talk about first the about water properties. So it's very important that you know the properties of water, as it's very important to life, not only to plants but all living organisms like people. So what are the extraordinary properties of water? So water is a molecule with a chemical formula H2O, or 2 oxygen, 2 hydrogen and oxygen. It's made up of 3 atoms, 1 oxygen and 2 hydrogen, as shown on the figure below. So water is also polar. In each water molecule, the oxygen atom attracts more than its fair share of electrons. That makes it polar. The oxygen end acts as negative, while the hydrogen end acts positive, causes the water to be polar. However, water is neutral, which is equal to the number of electrons and protons. 0 net charge. Hydrogen bonds exist between water molecules. It is formed between a highly electronegative atom of a polar molecule and a hydrogen. One hydrogen bond is weak, but many hydrogen bonds are strong. So the hydrogen bond, most of them are strong, as shown on the figure. So there's an interaction between water molecules. Negative oxygen end of one water molecule is attracted to the positive hydrogen end of another water molecule to form hydrogen bond. That's why water has a form and they are connected by bonds.
Hi, Mom.
What are the properties of water? Again, the properties of water: at sea level, pure water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. And the boiling temperature of water decreases at higher elevations or lower atmospheric pressure. For this reason, an egg will take longer to boil at a higher altitudes. So other properties of water are cohesion, adhesion, high specific heat, high heat of vaporization, and less dense as a solid. So let's discuss this one by one. Cohesion means attraction between particles of the same substance. So why water is attracted to itself? Because they are attracted to each other. This results in surface tension, a measure of the strength of water's surface. This produces a surface film on water that allows insects to walk on the surface of water. So it means cohesion, having, as shown in the figure, surface tension. So this is how cohesion is described on the figure, which helps insects walk across the water, but not humans, of course. So what's adhesion? Adhesion is the attraction between two different substances. Water will make hydrogen bonds with other surfaces such as glass, soil, plant tissues, and cotton. It has a capillary action, where water molecules will tow each other along with a thin glass tube. Example is the transpiration process, which plants and trees remove water from the soil and paper towels soak up in water. So this is the adhesion photos shows which causes capillary action, which gives water the ability to climb structure. So that's why water can travel or move from one place to another through capillary action, like a straw or lowered into the water. Adhesion also causes water, as shown on the figure, from spheres and hold onto plant leaves and attached to silken spider web. So, high specific heat is the amount of heat needed to raise or lower a 1 gram of a substance at 1 degree Celsius. So, water resists temperature change for both for heating and cooling. Water can absorb or release large amounts of heat energy with little change in actual temperature. High heat of vaporization also offers the amount of energy to convert 1 gram or a substance from a liquid to a gas. In order for water to evaporate, the hydrogen bonds must be broken. As water evaporates, it removes a lot of heat with it. So with high heat of vaporization, water's heat of vaporization is 540 cal per gram. In order for water to evaporate, each gram must gain 540 calories temperature. So temperature doesn't change by 100 degrees Celsius. As water evaporates, it removes a lot of heat with it as a cooling effect. Water vapor from a kind of global blanket which helps to keep the earth warm. The heat then radiated from the sun, warm surface of the earth is absorbed and held by the vapor. Water is less dense as a solid, so ice is less dense as a solid than as liquid. That's why ice floats. Liquid water has hydrogen bonds that are constantly being broken and reformed, while frozen water forms a crystal-like lattice whereby molecules are set at fixed distance. So water is less dense as a solid, which is ice and which is water on the figure. So as you can see, the less dense is on the right side of the figure. Water is less dense as solid. So the ice here is the one that is on the right side. So what is homeostasis? It's the ability to maintain a steady state. Despite changing conditions, water is important to this process because makes a good insulator, resists temperature change, universal solvent, coolant, and ice protects against temperature extremes or insulates frozen lakes. So it's just a matter of balance. So again, solutions and suspensions. Water is usually part of a mixture. There are two types of mixture, whether solution or suspension. So what's the difference between the two? A solution is a mixture in which two or more substances are uniformly distributed in another substance, while solute is the substance dissolved in the solution. This includes particles, which are maybe ions, atoms, or molecules. Solvent is the substance in which the solute is dissolved, while water is the universal solvent. So the figure here shows you the solute, which are ion of sodium, chloride, ion, and chlorine. Water as the solvent, so it becomes salt water solution. So solutions can be composed of varying proportion of a given solute in a given solvent, and they vary concentration or measurement of the amount of solute. A saturated solution is one in which no more solute can be dissolved, while aqueous solution means water, are universally important to living things. Dissociation of water is breaking apart of the water molecule into two ions of opposite charge due to strong attraction of oxygen atom of one molecule for hydrogen atom of another water molecule. As the figure shows you, the dissociation of water molecule. So water with hydrogen ion plus hydrogen oxide ion, and hydrogen plus water H with H3O or hydronium ion. So next is to show you a figure on the solution with the chlorine, sodium, and water solution. Substances that don't dissolve but separate into tiny pieces are called suspension. And while water keeps the pieces suspended so they don't settle out. So next are acids and bases. One of the most important aspects of a living system is the degree of the acidity or alkalinity. As shown on the figure, any liquid can be acidic or alkaline. One water molecule in 550 million naturally dissociates into hydrogen ion and a hydroxide ion, OH. So, this is shown on the figure below. The hydrogen ion, acid, and the hydroxide ion as base. One water, the pH scale the pH scale indicates the concentration of hydrogen ions, which ranges from 0 to 14. The pH of 7 is neutral, and the pH of 0 up to 7 is acidic, and the pH above 7 to 14 is basic. Each pH unit represents as a factor of 10 times change in concentration. So pH 3 is 10 times 10 times 10 or 1000 stronger than a pH of 6. So pH scale is in the logarithmic scale for comparing the relative concentration of hydronium ions and hydroxide ions in a solution. Ranges from 0 to 14. So each pH therefore is 10 times stronger than next. Example, pH 1 is 10 times stronger than pH 2. So as shown on the figure, the different liquids and different chemicals that shows their acidity. As you can see, the most acidic are the battery acid, the stomach acid, apple juice, then black coffee, followed by pH 7 with neutral pH to 10, antacid, hand soap, and baking soda. And from the most basic pH, we have household ammonia and drain cleaner. The lower the pH, the stronger the acid, and the higher the pH, the stronger the base. So the pH 7 is neutral. Acids has the number of hydronium ions in solution is greater than the number of hydroxide ions, as shown on the photo. So strong acids have a pH of 1 to 3, which produce lots of hydrogen ions. So as you can see on the figure here, they increase in acidity from neutral to from 7 pH 7 to 0. So the human blood is neutral, pure milk, and rainfall, and with an acid rain, and tomato becomes acidic to lemon juice and stomach acid. Bases, or the number of hydroxide ions in solution, is greater than the number of hydronium ions. So As shown on the figure are the properties of acids and bases in litmus indicator. So strong bases have a pH of 11 to 14, contain lots of hydroxide ions and fewer hydrogen ions. So as you can see on the photo, from neutral 7 to 14 alkaline, you have there the human blood, pure water, and sea level are actually basic, ammonia solution, bleach, and oven cleanser. Buffers are used to control pH, which is very important, and most enzymes function only with a very narrow pH, and control is accomplished with buffers made by the body. Buffers keep a neutral pH of 7. Example is the buffered aspirin. Buffers neutralize small amounts of either an acid or base and added to a solution. Complex buffering system maintains the pH values of your body's many fluids at normal and safe levels. Buffers weak acids or bases that react with strong acids or bases to prevent sharp sudden changes in pH is called neutralization and produced naturally by the body to maintain homeostasis. So Heinz vinegar is a weak acid while the cleaner is a weak base. So